Hello. Let's spend a few moments talking about the concept of logarithms. This may be a new topic for a lot of you, but I hope that after you watch this video that you'll find that it's really just a new name for something that you already know how to do. So let's talk about what is a logarithm, or commonly called logs. I want you to use your calculator to evaluate the expressions below. Log of 10, log of 100, log of 1000, log 1, log of 1 over 10. You're going to do this by using the key on the left called LOG. You'll press LOG and then insert the number inside the log, close parentheses, and enter. And I want you to pause the video for a few seconds, find these values, and then we'll pick up together in just a minute. Okay, I hope that you have found these values, so let's go through and make sure that you have the right one. For log of 10, did you find that is equal to 1? Good. Log of 100 is 2. Log of 1000 is 3, correct. Log 1 is 0. And log of 1 over 10, hopefully you found negative 1. So let's talk about what does this output value really mean. Can you notice some relationship between the number inside the log and the result? Well, do you know that 10 is really what? 10 to the first power. 100 is really 10 squared. 1000 is 10 cubed. 1 is 10 to the 0, right? Because anything to the 0 power is 1. And 1/10, you might have to think about this for a minute, but 1/10 is the same thing as 10 to the negative 1. So what does this log mean? Well, the log x is actually giving us the power of 10. It's a power of 10 that produces x. Log x is called the common log, and it is also written as log base 10 of x, meaning 10 to what power is x. Okay, so I said it was something that you've already seen, so understand that logarithm is a fancy way, if I can spell it correctly, sorry about that. Logarithm is just a fancy way to tell us to compute an exponent or power. Okay? So let's consider these expressions and see if we can kind of reason around what these would mean. Log base 2 of 8. If we use what we just talked about before when we had log base 10 of x, right, that case meant what power of 10 gives us x. Well, log base 2 of 8 would mean what power of 2, 2 to what power gives us 8? And if you know your powers well, what would that be? Yeah, 3. 2 to the third power is 8. What about log base 4 of 16? That would mean 4 to what power is 16? Good, that is just simply 2. Log base 3 of 1 means 3 to what power is 1? Yeah, we talked about with the exponential functions that anything to the 0 power is 1. So log base 3 of 1 has to be 0. Okay? So let's make a definition. When we see the expression y is equal to log base a of x, what we're really trying to say is what is a power of a that produces x? Okay? Y equals log base a of x. We're saying that y is the power of a that is equal to x. Okay? A is called the base, just like it is with an exponential expression. Okay? So if you can keep that in mind, that it's a base of some exponential expression, you'll be able to get this thing down. So it is the power or exponent of a that produces x. What are some restrictions that we might have here? Well, just like remember when we defined the exponential function, that base a had some restrictions. A could not be 1 and a had to be greater than 0, so that same thing applies here. Y is actually any real number because we can raise a to any power to get something. Now what about x? Well, x is the result of raising a to some power y. And just like we found with exponential functions, the range of an exponent was 0 to infinity. Well, that's the same thing here. So we're definitely going to connect an exponent and logarithm together, and that'll be in the next section. So let's make sure that we understand an exponential form and a logarithmic form to these expressions. When we say 3 squared is equal to 9, we could also write that with logarithms. 3 squared equals 9 means log base what? Well, log base 3, right? Our bases are still the same. Log base 3 of 9 is equal to 2, because remember the logarithm has to be equal to the power. Now let's go back the other direction. If we have log base 2 of 1/16 equals -4, well, to convert it from one form to the other, what we have to do is keep our base, right? So our base is 2. 2 to the -4 is equal to 1/16. What about the square root of 64 is equal to 8? Well, just recall that the square root of 64 is the same thing as what? 64 to the 1/2 power equals 8. So when we write that in terms of logarithms, we would have the log base what? What is our base? Yeah, our base is 64 of our result, which is 8, is equal to our power, which is 1/2. Okay? So the base, the result, and the power. So if you want to write it like this, a log base of our base of the result is equal to the power. In a better way, we can say this, that a to the y is equal to x is equivalent to log base a of x is equal to y. Now, the last one, let's do here. We have log 0.01 equals -2. Well, you just have to keep in mind that the common log is understood to have a log base 10. So the equivalent form is 10 to the -2 is equal to 0.01. Now, there's one other important log. We've talked about the common log, which is log base 10. There's also something called the natural log. The natural log is written as ln of x, and that's the way we generally read it. Ln of x is equal to the log base e. Do you remember that e we talked about with exponential functions? Recall that e is approximately 2.718. Log base e of x just means the power of e that produces x. So when we talk about the natural log of 1, we're saying e to what power gives us 1? Well, that has to be 0, right? Because e to the 0 power is 1. What about the natural log of e? That would mean e to what power is equal to e? Of course, that has to be e to the first power is e. What about natural log of e squared? That would mean e to what power gives us e squared? Well, that power has to be 2, right? It's kind of like solving those type 1 exponential equations. Natural log of 1/e, how could we evaluate that? Yeah, certainly you can use your calculator for these, and I'll show you that in the calculator video. But natural log of 1/e just by hand, think of it as e to what power gives us 1/e. Well, recall that 1 over e is the same thing as e to the negative 1, so our power is negative 1. Now, let's use that basic equivalency of logarithm and exponential expressions to write or to solve these equations. So to solve a log equation, what you're going to have to do is convert it to the exponential form. So when we see log base 6 of 36 equals x, we're going to write that as an equivalent exponential expression. So that would mean 6 to the x is equal to 36. Well, we know how to solve that. Convert both sides to the base of 6. So we get x has to be 2. What about log of x? Log base x of 16 equals 8. So that means x to the 8th power is equal to 16. Well, do you recall how to solve that? To get rid of the 8th, we can do 1 over 8. So that would be x is equal to 16 to the 1/8 power. And if you want to simplify that a little bit more, you actually can, because 16 is really 2 to the 4, right? And so we can simplify that. 4 times 1/8 would be 1/2. So this could also be written as 2 to the 1/2 or the square root of 2. Okay. What about log base 5 of x is equal to negative 1/2? The equivalent form for the exponential expression would be 5 to the negative 1/2 is equal to x. Well, remember, to get rid of a negative power, we have to do 1 over that. So this is really 1 over 5 to the 1/2 is equal to x. But just like we talked about in the last problem, 5 to the 1/2 is the same thing as the square root of 5. So we would have 1 over the square root of 5 is equal to x. What about log base 9/4 of x is equal to 3/2? So that would mean 9/4 to the 3/2 is equal to x. And just recall, with the fractional exponent, that means to do the square root of 9/4 cubed. Well, the square root of 9/4 is 3/2, and 3/2 cubed would be 27 over 8. Okay. And one last problem. The log base 4 of x plus 1 equals 2 means what? 4 squared is equal to x plus 1. Well, 4 squared is 16 is equal to x plus 1. So we can subtract 1 from both sides to get x is equal to 15. Okay? So the key thing to know here is when we see log base a of x equals y, we mean that a to the y is equal to x. So y is just the power of a that produces x. I'm going to do another video on all of the properties of logarithms, so make sure that you watch that so that you can be sure to have all the concepts down that you need to. Contact me if you have any questions. Thanks.